Let's do a review for Chapter 1, Introduction, the Scientific Method. We looked at the Monty Python video where they were trying to figure out if that woman was a witch. So yeah, they went through a parody of the whole scientific method. They had a problem. Was she a witch? Of course, they had to logically come up with an experiment. And they went through the whole process. They did the experiment, they collected data, they made a conclusion. And of course, it was flawed because of the logic and the equipment. The scientific method is no guarantee of good results, and that's okay. That's the way the scientific method works. It's a process. At the end of the process, you're allowed to go back and redo it, have somebody else check it out. So there'll be a question about the scientific method and perhaps the errors that may come up. You're going to get some kind of question that's just plain out there, going to make you think. Like the 9-dot problem. Connect all the dots with 4 straight continuous lines. And that's called thinking out of the box. In this course, you'll always be presented with things that will challenge your brain in a new way. And it's not just a matter of memorizing the formulas and then saying, oh, here's how you solve the problem. Yeah, there's going to be plenty of that too, but we're going to take it to the level where you have to think and think like a scientist. Kind of like when we did our review for Trig. We went outside and said, how tall is that flagpole? Well, I didn't tell you how to do it. You had to think about it. Of course, we had the meter stick casting a shadow, and the sun was at the same angle, similar triangles. You had to state that, and you did the ratio, and it worked out. And of course, we used trigonometry with the protractor that we used to sight to the top of the pole. So yeah, trig, ratios, all that stuff is going to be on there. I think everybody knows the trig formulas and how they work with the right triangle. And we even did a problem using the law of sines on a triangle that was not a right triangle. We'll just do one trig problem that may be a little bit harder. If you're looking for more trig review, I have that video posted, plus it's all in the notes. I got examples all worked out and the worksheet and all that stuff. So here we go. Given this problem, how long is the red line? 8 meters goes from here to here. Think about that. Using cosine, because this is the adjacent side to that angle, we can find the hypotenuse and get 17.4 meters. Just subtract 8 meters and you're going to get 9.43. This angle has to be 35. And using tangent, I get 6.6 meters. The point being is that you have to piece these parts together. It's not like there's one formula to solve for this answer. So you have to see it and go step by step. And if you want to know how to do all that trig stuff, like I say, go watch that review. It'll show you step by step. And we talked about units and conversions. Oh, like converting 3 meters per second to, say, miles per hour. You can put the meters on the bottom, miles on the top. These are conversion factors that you don't have to memorize them. I'll give them to you, but it's going to slow you down if you have to keep looking everything up. Some conversions you should just know how to do, especially when you're just moving the decimal point from, say, centimeters to meters, that sort of thing. And you just keep on going with your factor label method until you can cancel out all of the units and now you're left with miles per hour. Now, it's really important that with the units, that you do estimates. You're going to need to estimate various quantities. Length, say in meters or in centimeters. Mass, in kilograms or grams. Volume in, say, cubic centimeters or cubic meters. You've got a meter stick. You've got the cubic centimeters. You've got you got the scale with the gram scale. You can check all this stuff out at home, try it with different items, and then maybe you'll start to get a feel for it. And this is important when we do problems so that we can think about the meaning of the answer and not just believe whatever the calculator tells us. We want to see if it's realistic. Like what we did in the flagpole lab, we started out by asking, how tall do you think it looks, looking at the meter stick? And also, we're trying to get used to the metric system. Since this class is based on measurement and we can only measure to a certain degree, we're going to talk about Sig Figs in a general way. 3 Sig Figs should just about do it. No need to write down 10 digits. because you can't measure anything that closely.